Hi, my name is Sally Jones Diamond. I'm a research agronomist with Colorado State University's Crops Testing Program. Today I'm going to talk to you about our program, give you an overview, and how we provide unbiased data for crop production decisions. I wanted to start out by highlighting our personnel, starting with Dr. Jerry Johnson. He's a professor at CSU and he also oversees our program. He's our main connection to the department that we're housed in, which is Soil and Crop Sciences, and also an important connection to CSU Extension for us. Jerry works with companies that we have contracts with, and he also advises graduate students. Ed Asfield, shown on the left side of the picture here, is our boots on the ground guy. He works on all of our equipment and handles all the mechanics, doing upgrades to our equipment and doing just regular maintenance. He also handles the harvest and planting of our crop trials and is the direct contact person for a lot of our farmer cooperators. My role in the program is to work with seed company reps, both pre-season to get entries for our different trials, and also I work with them during the growing season to answer any questions. I go out into the field and take notes and assist with planting and harvesting. I plan the trials and then handle the data post-harvest. So quick outline of what I'm going to be talking about. I'll go over our role, the operations, variety selection, how we extend results, and collaborations we've done in the last few years. So for the past 11,000 years, every year, every farmer has to decide for every field which varieties to plant for any given crop. Our goal is to provide unbiased and reliable information, not only for farmers, but for other agronomists, seed companies, and other researchers. Our program has been around since the 1960s, and it's interesting, I put this picture up here. This is from the CSU archive, and you'll notice how folks used to dress up for what looks to be a field day for wheat. You'll notice everybody's in slacks and nice shirts, and some people have ties on, and so our field days look a little bit different. We dress a little bit more casual, but I think the information is still very useful and pertinent. So many states have variety testing programs through their land-grant universities. They might be structured a little bit differently than ours, though, and they might have multiple folks leading various crop trials. So maybe they have somebody running their corn trials and a different person running their soybean trials. That's pretty common in the Midwest. But all of these testing programs through these land-grant universities serve as what we call official variety trials for the state. And so we are one of those programs. So our variety trials help farmers and agronomists make variety decisions and recommendations, and companies make product selection and placement decisions. So we're testing for adaptability to our unique growing environments, especially in eastern Colorado. We have a wide range of production systems, and we hope to provide useful information to the folks that need it. We work with many different crops. The main ones that we work with are pictured here. We have sunflowers, winter wheat, grain sorghum, pinto beans, as well as corn. And a lot of these we do both dryland and irrigated trials. We also work with some lesser known and alternative crops and forages such as cowpeas. We had a trial in Akron last year looking at different cowpea varieties. We have a winter canola variety trial that we run every year through a collaboration with Mike Stam at Kansas State University. We occasionally do soybean trials, not very often though. We have forage sorghum trials down in southeast Colorado, and then we've also worked with camelina in the past. The types of testing that we conduct are mainly variety performance trials that are small plots and replicated. We had 38 of those trials last year, and in addition to that, we also do on-farm wheat test strips in collaboration with CSU extension agents in eastern Colorado. The small plot trials are really our bread and butter. They're the main core part of our program. But in addition to those, we also do agronomy trials, looking at things like populations, fertilizers, new soil amendments, and seed treatments. We test all sorts of different things. And last year we had 10 agronomy trials, and then we did around 13 of them the year prior to that. And those are usually done in cooperation with graduate students. This is a map showing our small plot trial locations. This includes spring planted crops such as corn, grain sorghum, sunflowers, and forage sorghum, in addition to beans, and then also winter wheat. So any given year we have 35 to 40 separate trials, including wheat. We work with CSU research stations at Rocky Ford, Walsh, Fruita, and Yellow Jacket, as well as the USDA ARS Research Center near Akron to do these trials. We also do on-farm strip tests in winter wheat, which I mentioned earlier. And so you can see on the right side there a map of where we had the trials. I believe this was in for the 2019-2020 growing season. These are, for the most part, the vast majority of these are planted on farmer fields, and so we use the farmer's equipment to plant and harvest these strips. And then the extension agents and myself and Jerry will usually go around and visit these fields once in the spring to talk with growers and just check on the trials. And then at harvest time, the agents will show up with a weigh wagon and weigh all the different varieties, and we'll compare those yields, and results are compiled across the locations and reported at the end of the season. So every year, every crop, and every field, these decisions have to be made, and it's one of many decisions that farmers and farm managers must make. And as you can see from the background image here, that is a lot of decisions, and it's important. So now we're going to go over the operations, kind of how we run our trials in our program. So the first thing we do usually around mid-January is gather varieties to test. We'll solicit entries from different seed companies to enter into our performance trials. Companies will pay a fee to test, and then all of those results are published at the end of the season and available to the public and to the companies. We work with commodity groups to ensure that we include hybrids that are of importance to farmers, or hybrids or varieties that are grown on a large number of acres, to make sure that we're making comparisons that make sense, that growers want to see. And those commodity groups also serve as a partial funding source for our program. So we work closely with the Colorado sorghum producers, the Colorado wheat, the sunflower, and the dry bean committees, and we've also worked with Colorado corn in the past to do trials. So then after we've gotten our entries, we'll go ahead and design the small plot trials. And so we will replicate the cultivars 3 to 4 times at each location and randomize those entries within each replicate. So it's called a randomized complete block design, and you can see on the table at the bottom kind of how that might work. Basically, you just want to make sure that you don't have the same order of entries across every single rep. And that's one way to help control variability within a trial, because you want to try and find as uniform a site as you can that avoids field edges, trees, hills, low areas, places that have uneven residue or weed patches. And so even if you take all that into account and you find a perfectly flat field spot, you're still going to have a little bit of variation within your trial that can't be controlled. And so replicating in those block designs, complete block designs, helps control some of that variability so that our data is more reliable and robust when we're looking at it at the end of the season. This is showing our row crop planter that we use to plant our corn, sunflower, dry bean, and sorghum trials. This is a small plot research planter that we got from Seed Research Equipment Solutions in Kansas. I think this used to be an old Syngenta research planter, and then when we purchased it, we made some upgrades to it, and it's been a great addition to our program. We can plant a different hybrid in each row if we need to. We usually don't. We do 2 or 4 row plots for our various trials. But the great thing about this planter is that it uses monosim seed meters, and so we get very good seed spacing within our row, and this is really important, especially in trials where we have low seeding rates, such as dryland corn or sunflower. It's been a huge improvement for us to have that seed singulation and have the consistent spacing between seeds. This planter also uses automatic trip. So what that means is when we're switching from one variety to the next, when we're planting a row, we might plant, say, 8 plots all in one pass. And so between every plot, this planter will drop the seed automatically at the beginning of the plot, and then at the end of the plot, which usually they're about 32 to 35 feet long for us, depending on what we want to do. But it will evacuate and clean out the extra seed in the chamber, as well as any extra seed left over on the plate before the next plot, and it does that on the go within 3 feet. And this prevents seed contamination between plots. And then if I turn on my little laser here, you can see at the back of the planter there's this evac tank, and there's actually 2 of them, one for every 2 rows, that holds all the seed that's vacuumed out at the end of all the plots. So it's very nice to have. We package all of our trials by seeds per plot or seeds per acre instead of using pounds per acre, and we do this because there is a very wide range in seed sizes for any of the different crops that we work on, and so we want to make sure that we have the same number of seeds in every plot, no matter the variety, so we can have a fair comparison among all the varieties. So we put the seed packets in planting order prior to getting to the field. You can see there in the picture on the right-hand side, that's kind of a view of the person sitting on the back of the planter. They have the seed box there with a packet full of seeds, 1 packet for each plot. And then we also have a copy of the plot map there with the planting order, and we'll double check that before we start going, and then on the go usually we'll check it. This is a picture of our small grain drill that we use to plant all of our winter wheat trials, along with our winter canola and camelina oilseed trials. This is guided by GPS for steering, and also to know when to hand trip for each going from one plot to another. So it doesn't have the automatic trip like our row crop planter, but it's still pretty accurate since we have the GPS light tripping, so that the person sitting on the back of the planter can see when the light comes on. There's actually 2 of them on the back there, 1 on each side of the person sitting there, and whenever that light comes on, we trip it and let the seed down and it'll drop down. And so this works very well in high residue fields. We use this often in no-till situations and in situations where there's lots of leftover residue, say stripper header wheat stubble or any other crop stubble. It does an excellent job planting through that stuff. After planting, we'll go out and check the trials a few times during the growing season to check for any issues with diseases or pests, and also to take field notes. And sometimes we get extension agents to help us take these notes, or graduate students or hourly helpers, because we have a lot of ground to cover. And so the types of notes that we will be taking include emergence and stand counts, flowering dates, plant heights, weeding, if there's any weeding that needs to be done either in the alleyways or within the plots that can't be controlled with herbicide, and as well as any lodging notes that we might need to take at the end of the growing season. This is a picture of our plot combine that we use to harvest all of our trials. It's a modified Case IH 1620 that we've done quite a bit of work to make it into a really useful plot combine. We use it with different headers. So we have the header there you see for the wheat trials. We use different ones for our milo and sunflower and dry beans. And so it's really versatile and the crops that we can use it for. And it's equipped with an H2 grain gauge weighing system from Harvest Master, and so that allows us to take really accurate readings on plot grain weights, as well as it'll take moisture readings and test weight readings on the go, and it'll take those readings from multiple samples within a plot as it's running through the system in the combine. After harvest, we have all of the data from the combine that we then have to take and calculate the plot yields. When we get the information off of our grain weighing system, it's in pounds per plot. And so I convert those into bushels per acre based on our plot sizes. And so all this data is compiled along with the in-season data for all of the trials. And then we do statistical analyses of the yield for the various trials. And there on the right side, you can see a heat map for yield. This was for one of our winter wheat trials. And so you can, from these maps, you can see how you might have some spatial variation within trials, and this might show up in especially some of the larger trials that we do. And there are ways that we can account for that in our statistical models when we're doing our analyses of these yield results. After harvest, our results are usually summarized in yield tables, such as the one you see here. This example is from a sunflower oil trial that we had in 2020. And what we do is we rank the entries, either the variety or the hybrid, here from highest to lowest yielding in this table. And we also include mean separation values here at the bottom, and this is the LSD, or the least significant difference. And what the LSD is the smallest significant difference between two yield means. So any differences that are larger than the LSD value is considered significantly different. And so if I click here and we see that the LSD at the p-value of 0.3 is 230 pounds per acre. And you can see here these top 4 hybrids are have the yields in bold. And what that means is that these 4 hybrids are not significantly different yielding from one another if we hold everything else equal, if we're not looking at things like test weight and other things of interest, just only looking at yield, then these 4 hybrids are equal. And so the way that we determine that these top 4 hybrids are equal is that we're just subtracting this LSD value, this 230 pounds per acre, from the yield of the top variety. So subtracting 230 from 2679, and then these other hybrids fall within that range. So the difference here between the number 1 and number 4 is less than 230 pounds per acre. And as you can see, we show 2 different LSD values at the bottom of our tables, and I'll give a short explanation here in a minute about why we do that. But if we use the LSD with a p-value of 0.05, you can see that that LSD value is larger, and so there's a larger group of hybrids that would be considered, not statistically speaking at least, different yielding from one another. And so why are we providing both of these different LSD values at the different p-values? And so farmers need protection from a high risk of false negatives. So if we think about the table on the previous slide, if we say that those top 9 hybrids are the same in terms of yield, when in fact one of them might be different yielding from the rest of them, if the farmer happens to plant that lower yielding variety or varieties, they're going to suffer economic loss from planting that lower yielding hybrid. And so others, such as seed companies that are looking to release new hybrids or varieties, they might need protection from a high risk of false positives. So saying that there is a difference among these different hybrids when in fact they're really equal yielding. And if you think about that in terms of the farmer perspective, that doesn't matter as much because you're not going to suffer economic loss if you're planting hybrids that are equal yielding. And so that's why we say farmers should use a p-value of 0.3 for variety selection, and companies may want to use a p-value of 0.05. And as we decrease that p-value, the LSD value increases, right? So we went from 200 and some pounds per bushel up to 440. And so as that LSD value increases, it increases the chance of us missing those real differences among the hybrid yields. And the statistical speak for this is we're trying to control for type 1 and type 2 errors. But just to keep it simple, I'm using different terms here. And so using this p-value of 0.3 is just a happy medium that balances the confidence of both things of finding real differences among hybrids and also trying not to miss the real differences. So trying to control for both of these errors, they are inversely related but not linearly. And so it's kind of a curve on how these are related. And so we're trying to balance the 2 different risks. Now we're going to dive into the variety selection decisions and how we help growers make these decisions. So how do farmers choose which varieties to plant? Are they looking at things such as yield, seed costs, different traits of interest, maturities, or maybe they're looking at things that are a little less tangible, such as tradition, what's been grown on the farm for the last 10 or 15 years, or maybe they're going by what their advisor is telling them, or maybe all of the above. So these decisions are not as simple as choosing the top yielding hybrid in a specific trial. And our technical reports, like the one you see here on the right-hand side, these are called making better decisions in light of these selection decisions that are having to be made every year. And there's a lot of money on the line for producers and farm managers to make these variety selection decisions. And so we'll talk a little bit later on about how you can compare these varieties based on other selection considerations other than just yield. So new varieties improve things such as crop yield. That's the main characteristic that a lot of people are looking at. But they also might be improving adaptability for a certain environment, such as specific maturity maybe it's drought tolerance or seedling vigor for planting earlier, disease tolerance or resistance, herbicide tolerance, or even end-use qualities. And so the example here on the right-hand side is from winter wheat, and looking at the coaxium wheat varieties that have been released in the last few years, allowing for better control of annual grassy weeds. This is an example of a dryland wheat decision tree that we put in our Making Better Decisions reports. Like the one that I showed you for the corn, we do those reports for winter wheat, corn, dry beans, and as well as sorghum and sunflowers. And so in these reports, we try and include more than just the yield tables. We try and include other things that might help folks make these selection decisions. And so you can see here that we're not just looking at yield. We're looking at maybe the biggest decision when you're looking at winter wheat, which is which market class do I want to grow? Do I want to grow hard white winter wheat, or do I want to grow hard red winter wheat? And then after you determine that, you can either look at if you're going to plant hard white wheat, if that is going to have a premium associated with the quality or the test weight and protein, or if there's not going to be a premium associated with it. And then if we look at hard red winter wheat, we can look and see that there's a few more options there. You can get something that has herbicide tolerance to those grassy weed herbicides, or maybe you don't care about herbicide tolerance for those and you just want to focus on a traditional variety. Or maybe you're in sawfly country and you need something that has really good sawfly resistance. And so then you can see the decision goes down even further. When you're looking at herbicide tolerance, we have Clearfield or Beyond, or the coaxium that uses the aggressor herbicide. And then we broke it apart here. If we're looking at no herbicide tolerance, you can see it's different maturities. So we have early maturity, medium, and medium lates. And maybe you want to choose a variety that's, say, an early maturity, such as Langan, that's been traditionally high yielding. Maybe you want something that's a little bit later maturity, or you have a specific field where you have a grassy weed issue like downy brome, and you want to put something in like a coaxium variety. So you can spread out your risk, and you don't want to just plant one variety for your whole farm. So this decision flow moves based on the importance of the questions that we're trying to answer. And then the other important thing that we included in this particular decision tree was disease ratings. So you can see we have the YR, which is stripe rust rating, and then we also have wheat streak mosaic virus ratings for all of these different varieties, so that everything that might be of major importance is in one spot. And all of the varieties that are in this decision tree have been in our trials for multiple years. Most of them are above average yielding, except for a select one or two, such as Spur is not above average yielding, but if you have severe sawfly pressure, then it might be one that you want to look at, even though it has a yield drag. Since it's not perfectly adapted in terms of maturity, it is adapted in terms of sawfly resistance. This is an example of another yield table that we published. This is showing our winter wheat results across different dryland locations, with the locations going across the top here. This is for the 2020 year, and so these wheat trials that we run are uniform. So all of the varieties are entered at every location for the 11 dryland locations that we run, and then a separate set of uniform varieties across 3 irrigated locations every year. And this allows us to combine the yield data from multiple locations across multiple locations for a single year. And so then we rank these varieties based on highest to lowest yield, based on the average yield across all of those different locations. And so that just allows us to have more robust data. And as you can see, Snowmass 2 was the highest yielding variety in 2020. but it wasn't the highest yielding variety at every single location. And so it just goes to show that there's a genotype by environment interaction a lot of years when you're looking at different locations. And so it's important to look at more than one location and even across multiple years if you can, if the same variety is entered across years. And so then this next table, we see that we have multi-year and multi-location data. So this is a 3-year summary from 2018 through 2020 of our dryland winter wheat trials. You can see that Langen tops the trial. Snowmass 2, that was the top in 2020, moved down to 3rd place, although the difference in yield in terms of bushels per acre is pretty small. And so we want to encourage farmers to look at this table with the 3-year averages when they're trying to make a variety selection decision. And you'll see a lot of these varieties were included in our variety selection decision tree that we talked about on a previous slide. And so looking at multi-year, multi-location data is a much higher predictor of how a variety will perform on your farm in any given year than looking at single year, single location data, even if it's on or near your farm. And I also wanted to point it out that this is not the complete table here. There's a lot more varieties on the bottom. I just cut it off so that you could read what was there. So like I said, we want to look for multi-location and multi-year data when we're trying to make these variety selection decisions. We encourage company entrants to enter varieties at multiple sites and in multiple years to get more robust data on that particular cultivar and to get an idea of yield stability. We try to provide that information for various crops. Sometimes, though, we have a low carryover from year to year for testing hybrids, especially in things like corn where you just see high turnover rates. But this year-to-year variation is not controllable in field trial situations. And so we tell farmers to plant multiple varieties or hybrids in a single year to lower their risk. And just know that the worst predictor of how a variety will perform in a future year is how it performed this year at one location. And this graph here that I'm showing you just goes to prove that point. This was done by Dr. Scott Haley, who is a former wheat breeder at CSU. He published this in our 2016 and our 2019 wheat Making Better Decisions publications. And so this is looking at the predictability. So this is basically 0% predictability up to 100% predictability. And then the number of trial locations here across the x-axis, it goes up to 20 trial locations. And then the different lines here are for the multiple years. So if we look at this bottom line here, you can see that the predictability never gets above 40% when we're looking at 1 year of data, even if we have 20 different trial locations. But as soon as you jump up to 2 years of data, this line with the triangles here, you can see that our predictability jumps up quite a bit. It's about 50% now, even with half the number of locations, with only 10 locations. And then of course, as you move up in years, 3 years, you get even more predictability, and then 4 years, it improves more, but not as high of a jump. And so it's just trying to prove and show that point that you really want to look at multi-year and multi-location data. So now going into how we extend our results to growers. The first thing that the first direction that we point folks to is usually our website. We redid this website in early 2019, so about 2 years ago. This is a major improvement over what we had. We tried to make it easy to find info, so we have it broken apart here by crop, by the major crops. And then we post all of our trial results here as soon as possible after harvest. And so if you click on any particular crop page, it'll have a list of the trial results for that year, as well as our Making Better Decisions publications going back, I think, almost 20 years. We have those. And so you can type in csukrops.com and that'll redirect you to a .edu web address where our website is housed now. And we're also on Twitter at CSU Crops. This is an example of one of our crop pages. So if you were to click on the corn button from our home page, it would bring you here. And this just lists our 2020 trial results broken apart by dryland and irrigated trials. And so you can go down the list and look at the different trial results that we had. And then below this, if you were to scroll down, you would also see the technical reports going back, like I said, quite a few years that you can look at. We compile these results into one place for every year. So if we look at the results for 2020, all of those are going to be included, all of those tables are going to be included in a publication like this, only it would be for corn instead of dry beans, obviously. And so all that's compiled together in one publication, in one PDF that you can look at, along with other information. Like I had mentioned earlier, for wheat, we include lots of different information, such as the variety descriptions. We have articles from different experts. Maybe we have an article about pests or diseases in a particular crop that's of importance. And so we try to include pertinent information for that crop being grown in Colorado. Another way that we extend results is by doing field days during the growing season. So you can see on the left-hand side a flyer from our wheat field days that we held in 2019. We hold those across 11 different locations, a couple irrigated as well as dryland locations. And we try and have experts there to talk about the crop and answer any questions that growers might have about particular varieties or growing challenges, and just provide a forum for growers to get together and talk, and as well as having experts there as well to help answer any questions. And then on the right hand side, you can see we also do some sorghum field days for grain sorghum at a few different locations. And a lot of these field days are done in collaboration or in conjunction with the grower commodity groups for that crop, or even seed companies that might help provide some funding or sponsorship support. This is a picture of a grain sorghum field day that we had down at Sheridan Lake a couple years ago. You can see that we've gotten some pretty good participation in these and good turnout. And it's a great way for farmers to get out and see new hybrids and compare them to ones that they may be more familiar with. And so just getting out there to see them and listen to the company reps talk about them is really useful. And something that we did that was new in 2020 due to COVID-19 was that we put our wheat field days online, and we posted videos on YouTube, and these are still posted on the CSU Extension channel if you still want to go look at them. Some of the longer videos here, we have Dr. Scott Haley, the former wheat breeder, giving a walkthrough of the trial at Orchard, which is what he would traditionally do at an in-person field day. And then he also did a walkthrough at Arapahoe and one of our irrigated locations. And then the other videos are people talking about specific things that are pertinent to winter wheat production in Colorado, as well as folks talking about, company folks talking about their specific varieties entered in the trials. And so those are shorter clips. Not all of them are half an hour long. A lot of them are less than 5 or 10 minutes. So next I'm going to go over some of the collaborations that we've done in the past few years. The first collaboration I'm going to talk about is for grain sorghum cold tolerance. We conducted this trial in 2018 and 2019 at Akron at the USDA ARS Research Center. This was coordinated by Dr. Krishna Jagadish, and Dr. Ram Perumal from Kansas State University. Krishna is an abiotic stress physiologist, and Ram is a sorghum breeder based in Hays, Kansas. And so what we were looking at were different sorghum lines that we planted early, which in our case was May 1st for our growing region in northeast Colorado, into dryland conditions with fairly heavy residue, like you can see from the picture there. And so we were monitoring emergence and taking stand counts about every 3 to 4 days during the early growth period and emergence to see how long it was taking for different lines to come up and how vigorous they were after they came up. So looking at things like early growth, and then also looking for stress. And so you can see from the picture here that the plant has some cold stress going on. It's turning purple there at the stem and the bottom part of the leaf, which means it's not very happy to be up that early. And so we took these trials to harvest and gathered green yield and also quality data. And so some preliminary results that we found were that early planting resulted in a longer duration to flowering, and that these hybrids or varieties accumulated a higher number of growing degree units during grain fill as well. And so what we noticed in particular at the Akron trial was that we had very slow emergence when we planted early. The soil temperature in 2019 when we planted was around 49 degrees, which is too cold or lower than the recommendation for grain sorghum. And so it just sat there for a couple weeks until the soil temps came up. And so it was interesting to observe this, and we're working on a publication now to publish these results in a peer-reviewed journal. Another trial that we've done in collaboration with Dr. Wilma Trujillo and the Colorado sorghum producers is a grain sorghum nitrogen study. And this was done from 2017 through 2019 in northeast Colorado, as well as at Sheridan Lake in southeast Colorado. We looked at 4 different hybrids and 4 different nitrogen rates, ranging from 0 to 160 pounds per acre. And the results varied across the environments and among the hybrids. We had 2 different maturity groups for the hybrids. We had 2 early hybrids and 2 medium early hybrids. And so we saw a difference between the maturity classes, but we didn't see a real response in locations that had high residual nitrogen, which would be expected, but we saw really good response in lower nitrogen response in lower nitrogen environments, excuse me. So in Otis in 2019, as an example, we started out with a little less than 40 pounds per acre of nitrogen in the top 2 feet of the soil profile, and we saw a really good response of additional nitrogen up to 80 pounds added. And then at Sheridan Lake and at Akron, at a different year, we had variable responses to nitrogen depending on the hybrid. And so we hope to do some more work on this in the future. We didn't do this trial in 2020 due to COVID. We didn't know what our personnel situation would look like if we'd have enough hourly help to do this trial, so we didn't do it last year. But we also hope to do a multi-state project looking at updating nitrogen fertilizer recommendations for the High Plains region. And so this data has been presented at a few sorghum meetings that have been held in the spring with the Colorado sorghum producers. And eventually we'll get it put into a technical report as well. The last sorghum project that we've worked on that I wanted to highlight was done in conjunction with the USDA ARS, both the Research Center in Akron and the Water Management and Systems Research Unit based out of Fort Collins. Dr. Greg McMaster, Merle Vigil, and Debbie Edmonds, as well as Jerry and myself, worked on this. And we were using the Phenology MMS or modular modeling system to help come up with probabilities of early maturity hybrids reaching physiological maturity across 7 different planting dates, and 9 locations in Northeast Colorado using either water-stressed or non-water stressed phenological parameters. And so just to keep it simple, I just put Akron here in this table, and so you can see the probability of reaching maturity ranges from a little over 90% down to around 25% if you were to wait until mid-June to plant. And so this, the other locations that were included were Sterling, Greeley, and a few other places in Northeast Colorado. And so if you're interested in looking at the full article, it is open source. You can Google the article title here and check it out, or you can send me an email and I'd be happy to send it to you. But it's really interesting data, and I think we're going to work on some more data similar to this in future years in collaboration with them. Some work that we've done in winter wheat in conjunction with a couple companies, but the one I'm going to talk about in this case is from Indigo Ag, is looking at the effects of some microbiological seed treatment products at different nutrient management levels and across different environments. So we provide unbiased third-party testing for new products from the ag industry, and for this particular project, we did larger studies looking at multiple seed treatments, like 20 or so, over the last couple seasons at our Akron location. And then last year and this year, they actually entered 2 different seed treatment products into our regular wheat variety trials as treatments on the variety Langan. And so if you want to look at those results from last year, they're in the tables listed under the Indigo brand. And this biotrinsic branding or product is a collection of seed treatments that use beneficial microbes to help improve plant growth. And they're saying that these are naturally occurring microbes, and they're using endophytes to help incorporate these into plants, and it's supposed to increase yield. So we're just looking to test these products. Farmers can look at the results before they decide if they want to look at using them on their own farm. And we provide those unbiased and reliable data for both growers and companies to help make decisions. Another project that we've done looking at seed treatments was looking at treatments on soybean seed for Valent Biosciences. We were evaluating the effect of mycorrhizal fungi and additives on soybeans across a range of different product rates over the course of 2 years. And this particular trial was done near Yuma, Colorado. And so these products were that we tested were supposed to promote crop quality as well as increase yield and plant and soil health. The last project that I wanted to highlight was one that we did looking at corn drought tolerance with grant funding from Colorado Corn. Drought has a major impact on dryland corn yield in eastern Colorado, and we wanted to see how we could mitigate that risk with drought-tolerant hybrids possibly. And so we looked at 12 different hybrids from 4 different seed companies and planted those at 3 different seeding rates across 3 site years at Akron and Daly from 2014 through 2016. And what we found was that we didn't see a yield improvement with drought-tolerant hybrids over the regular hybrids across those 3 site years. And so if you want to look more into the data and the results, those are included in our Making Better Decisions corn reports from 2016 and 2014, if you'd like to look at those. Finally, I wanted to highlight some of the work that our current graduate students have been doing. And so on the left-hand side is Roger Tyler, who is a PhD student who built his own weather stations and is using them at the wheat trial locations to hopefully improve wheat variety recommendations for specific growing environments. And so these stations have been out at our 11 different trial locations the last 2 years to gather information. And then the student on the right is Danica Kluth. She's a master's student working to determine whether varieties need to be fertilized differently in regards to nitrogen. and to help come up with new wheat fertilizer recommendations for Colorado. And she was also looking at sulfur as well, sulfur application to wheat in addition to nitrogen. So I just wanted to highlight some other collaborators that we've worked with over the years. The one projects that I just talked about were specific examples, but it certainly was not all of the projects that we've helped with in the last few years. And so we work with grower associations, seed companies, and other universities to conduct research and provide information for seed companies and producers to make better decisions. So I just wanted to acknowledge that our work would not be possible without all of our collaborators. And that's all I have. So thank you for your time today. If you want to see any of the information that I kind of talked about and gave an overview of, you can go to our website. You can see the two different web addresses. They'll take you to the same page, or you can send me an email there or give me a call. Thank you.